All right. Ladies and gentlemen, please, if you don't already have your notes out, take your notes out. This is going to be Math 7, so M7. And today we are doing lesson 1-5. Lesson 1-5. I would like to point your attention to the online. I'm not going to show it to you right now, but the homework for the entire section and all the dates it's due for the next 2 weeks has been put up online. So if you're curious about, like, you know you're going to miss a couple of days and you need to look ahead, you can look ahead and see what it is you're going to miss. Okay? If you ask me, I will just point you to the website, so you might as well get familiar with it now. All right, 1-5, measuring in metric units. Okay. Believe it or not, this is not terribly difficult. It's not. Okay? Actually, measuring in American units is harder than measuring in metric units. Okay? So I'm going to kind of get started a little bit by doing some examples today. I do really like this topic because it applies so well to what we do in science. This year in science, we're going to be using a lot of metric units. Okay? All right, so let's start with this idea of tens. Okay? Tens. All right, I'm going to start with a 1. Okay? 1, right in the middle. Okay? The metric system. All right, now, the metric system is based on multiples of 10. Okay, that's what it's based on. And there are lots of different types of what we call base units in the metric system. So the base units are always right with this idea of being with 1. So I'm going to go ahead and put base units. And believe it or not, this ties in with our lesson tomorrow in science. So actually, you're going to be kind of hearing the same thing twice. Okay? So it's really actually to your advantage. You're actually going to be ahead of all the other students in science tomorrow. Okay. Now, some base units would be meters in the metric system. M stands for meters. Okay, so I'm just going to put a little arrow, meters. Okay. Other base units might be liters, so capital L. And we're familiar with this idea of liters because we drink 1 liter bottles of pop or 2 liter bottles of pop or 2 liters of water, etc. So liters. Okay. And seconds, believe it or not, seconds is also a unit that we use in the metric system, seconds. Just going to ignore. Okay, seconds. Seconds. All right, now here's the deal. The next one up is we just either multiply or divide by 10. Okay, so if we're going smaller, okay, so it's kind of like a number line. If we're going smaller, we would do what? Multiply or divide? Mr. Rotz. Yeah, we would divide by 10. And if we want to go larger, so on the flip side, if we want to make the numbers larger, would we multiply or divide by 10? Mr. Brown? We would multiply by 10. Okay, so let's just go ahead and go the next couple of steps both directions. What is 1 times 10? Amaya? 10. It's 10, yeah. So the next step here is 10. All right, now 10 times 10 is? 100. And 100 times 10 is? 1,000. And I know it's a little bit hard to see. So I'm going to go ahead and just adjust slightly. Okay, now on the other direction, this is actually not so hard. Since we've already said that going smaller means division, we would say that 1 divided by 10 would be the first step down. Okay, notice that I'm just saying 1 divided by 10. Would be the next step. What would be the one next after that? 1 divided by what? Braden. Yeah, actually, we're just taking the numbers from the other side and putting them on the bottom of a fraction, right? So we have 1 divided by 100 here. So it's kind of like the bottom looks like it's going up, but what happens when your denominator gets really, really, really big like this? What happens to the total fraction? Does it get big or small? Say it louder, Todd.
Small.
Yeah, smaller, right? I'd rather have 1/10 of a piece of Oreo pie instead of 1/100th of a piece of Oreo pie, because 1/100th is really small. Okay? All right, so it's really, really small. All right, now, I am going to use the idea of meters for just a minute. So I'm going to highlight that just so that we can kind of focus in on that. Meters. That is going to be our kind of our focal point today. Okay? We use meters as kind of a common base unit. So actually, it's going to be helpful if I pull out a meter stick. So I'm going to pull out a meter stick. Yes?
For the 1 divided by 100, there would be 1 divided by 1,000.
There would be a 1 divided by 1,000, and then there'd be a 1 divided by 10,000, and then a 1 divided by 100,000, and then a 1 divided by 1,000,000, and etc. It'd keep going. So yes, believe it or not, the metric system can go as large or as small as we want. For instance, when we're talking about how fast light moves, we're into the billions. If we're talking about how small light is, like if we were to measure the distance between like a little bit of light, we're talking about 1/billionth. Like we're talking something with 9 zeros in the denominator.
Yeah,
Okay.
How do you measure light?
How do you measure light? You're going to learn this year in physics. Okay. All right, so this is 1 meter. 1 meter. It's the length 1 meter. Okay, so I have this up here on the board, and that would be my base unit meters. Okay, so if I had 10 of these, okay, that would mean I'd have 10 meters. I'd take this and I'd multiply it by 10. If I wanted 100 meters, okay, 100. 1,000 meters, I'd have 1,000 of these. Okay. I also can take 1/10, and believe it or not, meter sticks are divided up very nicely so that we can work with the smaller end of things. So 1 meter, if I take and divide by 10, we see 10, 20, 30, 40. This right here is 1/10 of a meter. This would be 2/10 of a meter. It's 2 1/10 sections. 3/10 of a meter, 3 1/10 sections, etc. Now, 1/100th would mean I would divide this stick into 100 equal pieces. Does anyone know what we call 1/100th of a meter? It's a very common measurement. You've probably used it before, yeah? Yeah, it's a centimeter. Okay? So let's jump over a little bit. This, ladies and gentlemen, in the 1/100th range is known as a centimeter. Oops, don't want to do that. As the centimeter. Okay? 1/100th of a meter is 1 centimeter. One centimeter. Believe it or not, and I'm going to just write the word centimeter under that. One-10th is known as a decimeter. It's dm, decimeter. Okay. Now, 10 is not a common measurement, so I'm not going to worry about it right now, and neither is 100. But 1,000 meters is actually a very common measurement. Yes. A kilometer or kilometer. Yes. Okay, so on the flip side, a kilometer or a kilometer. I actually used to have a van that my speedometer was in kilometers, not miles per hour. I always had to convert on the fly. Okay? It was made in Canada.
Oh, yeah.
In Canada, they use the metric system. So all of their speedometers are in kilometers per hour. Okay?
Oh, those Canadians.
I know, right? They've got it down. So meters, liters, seconds. These are what we call base units. We have centimeter, means 1/100th. That word centi right here, that actually means 1/100th. It's called a prefix. Decimeter, notice it's a little bit, it's a couple of letters out in front of our base unit. That deci means 1/10. What do you think kilo means? 1,000. So if I say I have a kilogram, what do you think you could infer from that? Yes. 1,000 grams, right. Kiloseconds. How many seconds? 1,000 seconds. Okay. Kilo marshmallows. Oh yeah, it's my fave. Jackson Trader.
Bread and butter.
1,000 marshmallows. Kilo Jackson Traders. 1,000 Jackson Traders. Cloning has taken effect. And that's basically what you call Santa's little elves. Okay? Now,
1,000 jackets.
they can work at malls. That's awesome. Okay. So we basically, the metric system is designed to be easy, right? It's either dividing by 10 or multiplying by 10. It's meant to have these little words out front. So centimeter, decimeter, kilometer. We can do this for any one of our base units. Centiliter, deciliter, kiloliter. Centisecond, decasecond, kilosecond. One of the most common we use is millisecond. Okay? So we use the metric system because these little words out front tell us very quickly where it is. If I say kilo, your brain should instantly, and it will eventually, jump to 1,000. If I say centi, your brain should jump to, it's 1/100th. It's only a very small piece. Okay? So that's how the metric system works. Okay, that's how the metric system works. Now, look in your book, please. They've given you a very simple chart, okay, on page 27. And I'm actually going to take a picture and put it in our notes so that we have something to refer to here. So I'm going to go ahead and add a picture. Okay, take a look. This is from your book. Okay? Now, what can you tell me right off the bat about kilometer? Okay, what are they putting in front of the M there? What little symbol? Okay, what are they putting in front of the M? Yeah. No. This is a letter. I'll zoom in for you. Right here. What letter is in front of the M? Right here. Okay. That K stands for kilo, okay? Means 1,000. Hecto, what's that? No. But you should be making maybe some notes about what I'm saying, okay? So kilo means 1,000. What about hecto?
The hectometer.
Yes, 100. And if you look in your book, they use the example of hectometer, HM, meaning 100 meters. What is the one that comes after hecto? Hecto.
Hectokilometer.
Yes, Jayla.
Decameter.
Deca. So what would I put here? I put kilo. I put hecto. What would I put here? I put 10 right here on the right-hand side, but what would I put under the word hecto? Starts with D, ends with eka. Deca, thank you. And she's absolutely right, it's 10. Now, notice for the regular unit, there's no word. So we refer to that as the base. And the base is always 1. Kind of bringing it back. All right, now, that is if we are increasing. So this is getting larger, okay, increasing. But what if we were getting smaller, okay? So what if I wanted to go down, okay? We would start with the base of 1. But then what's the next little word that we have to worry about? Yes. Deci. Deci actually comes from kind of similar to decimal. It means part of 1. So deci, except deci refers very carefully to what decimal value? Mr. Henney. A tenth. Also so it's either 0.1 or 1 over 10. Those are the same thing, by the way. This is the decimal version of this fraction. Okay? The decimal version of this fraction. So, Finn, are these the same thing?
Yeah.
Yes, they are. Okay. Now, what's the next little part that I have to worry about? Sophia. Centi! Yes. That's right. Centi. 0.01. Okay. Or what fraction? Mr. Biebrick. 1/100th. 1 over 100. Okay. Last but not least, milli. Not to refer to the 8th grader. Okay. 0.001 or what, Jackson? 1/1000th. The millimeter, that's a very good representation. So if I'm going to say how much of a total meter stick is 1 millimeter, it's one of these tiny little dashes here. Okay, how many pieces did I divide this up into to get millimeters? Yeah.
A million.
Not a million. So think about milli. Think about this. Think about this. Mr. Yoder. 1,000. There are 1,000 millimeters on 1 meter stick. So there are 1,000 millimeters, 100 centimeters, because it's 1/100th, 1 centimeter, right here, 1/100th the total. There is 10 decimeters. This is a decimeter right here. Okay, 1/10. There's another 10th. There's another 10th, etc. And then the base, 1 meter. This is it, 1 meter. This is 1 meter. This is 10 decimeters. This is 100 centimeters. This is 1,000 millimeters. Right here. Okay? If I had 10 of these, it'd be how many? Yes. A decameter. If I had 100? Somebody? I know you know the answer. Somebody else? Amaya? It'd be 1 zactometer. And if I had 1,000 of these, Mr. Biebrick? A kilometer. Kilometer or a kilometer. Okay? So this is how the metric system works. This is how the metric system works. And one of the things that we are going to have to do in science, especially this year, is we're going to have to be able to convert. Okay? Convert. All right, so please turn to the homework part of this unit. And let's work through a couple different examples so you know how to kind of do this. Okay? All right. Now, I think that you'll probably be able to kind of figure this out. One of the things you have to understand or be able to do is figure out, are you going from a large unit to a small unit, or are you going from a small unit to a large unit? That's what you have to, one of the things you have to be able to figure out. So take a look at number 2 for a moment. Okay, take a look at number 2 for a moment. Okay, what are the instructions here? Jackson.
What number should you multiply by change each unit?
Okay, so let's do this. We are going from grams to what? What's it say? Number 2. Yes. Grams to kilograms. Grams to kilograms. Okay? Let me give you some equivalents here. Okay? Let me give you some equivalents. Let's say that I had 1,000 grams. Okay, fair enough. Mr. Sacchusi? 1. Correct. 1,000 grams is 1 kilogram. What about 2,000 grams? Yeah, it would be 2 kilograms. What about 3,500 grams? Give it a shot, Mr. Rotz. It'd be 3.5 kilograms. Okay, 3.5 kilograms. So what am I multiplying these by to get to these? I'm going from large numbers to small numbers. So am I going to multiply by 1,000? Am I multiplying 1,000 by 1,000? No, I'm definitely not doing that. I actually have to multiply by, well, if I multiply by 1, I get 1,000 times 1 is 1,000. Well, that doesn't look quite like 1,000. It's missing a few zeros. Okay, I'm going to have to multiply by a fraction. I'm going to have to multiply by a fraction. I'm actually going to have to multiply by something small to get this way down. Okay, get it way down. All right, so in this particular situation, I'd have to multiply this to go from grams to kilograms. I'd have to multiply by 1 over 1,000. Now, if I do that each time, and I multiply here by 1 over 1,000, okay? How many of you have ever done where you can kind of cancel zeros? How many of you have ever done that where you can cancel zeros when you're multiplying two things? Let's just pull, I'm going to pull it off to the bottom here. Okay, I want to look at this for just a second. 1,000 times 1 over 1,000. Okay? When I'm multiplying these, how else could I write this number? Mr. Biebrick. I could do it as 1,000 over 1. Okay? Any number like this can always be written over 1. That's a rule. That's a rule that we know and have established in previous math classes. So if I multiply through the top, which is what I do with fractions, I get 1,000 on top. What do I get on the bottom? 1,000 on the bottom. What is 1,000 over 1,000? So if we're looking at the big picture here, if I take 1,000 and multiply it by 1,000th, like I did here, I get 1. Now, if this number changes to 2,000, I end up with 2,000 over 1,000. That's like 2 over 1, which is 2. If I take 3,500 and divide it by 1,000, I get 3,500 or over 1,000. That's like 3.5 over 1, so that's 3.5. Okay? Okay. I'm not expecting you to get this perfect tonight, but I do want you to try and think through some of these things. It might help to make a list of examples when working through problems 3 and 4 tonight. Okay? All right, moving on. Okay? I want you to look at number 11 for me, please. Number 11. In this one, we are going from kilograms to grams in the opposite direction. Huh? Okay, that's great. Moving on. If we're going from kilograms to grams, okay? If we're going from kilograms to grams, in this particular case, they're asking us what would be the equivalent? They're saying that we have 0.9 kilograms. How many grams do you think that is? Okay. Well, first of all, a kilogram is how many grams total? 1,000. What's 0.9 of 1,000? You want to take a shot?
900.
Excellent. That's the answer. I want you to, it's not as purely as simple as just doing the math. You actually kind of maybe have to ask yourself some questions. If this is 0.9 kilograms, I know that a kilogram is how many grams? It's 1,000. 0.9 of 1,000 is 900. Okay, so these are some of the connections that you need to make. I'm going to give you kind of a way to kind of work through this. If you're going from small to large, I'm going to go back a couple pages here. If you are going in this direction, you're going from small to large.
Number will be small.
It will be divided.
So let's say you're going from milli to meter. You're going from milli to meter. Okay, if you're going in this direction. So if you needed to go from millimeters to meters, you would multiply by these numbers. Basically, that's what you're doing. You're going to multiply by the numbers on the bottom here. Not necessarily. Okay? So if I'm going from 7 millimeters to meters, 7 millimeters to meters, I would multiply by 0.001. That's what I would do. I would do 7 times 0.001, and that would shift me all the way over to meters. Okay? Let me erase this and kind of... It won't. You're always going to be asked pretty much to work towards meters. So if I am working, if I'm going to meters in this direction, if I'm going in this direction, if I'm going in this direction or this direction, you're going to work with the numbers in the bottom. Okay, so I'm going to go ahead and put little squares around them. The 1,000, the 100, the 10, the 1, the 0.1, the 0.01, the 0.001. If you are going from meters to millimeters, if you're going from meters to millimeters, okay, you're going to divide by the number you're going to. If you're going from millimeters to meters, you multiply by the number that you're coming from. Hence the reason the arrows. If you're going from meters to kilometers, you divide by the number you're going to, and down here you multiply. I'm going to give you an example on how to use this. Finn, I want to say that I'm going from 8 centimeters to meters. Okay, first of all, where am I at on the chart? What operation am I going to tell you to do? Okay, yes? Multiply. I'm going from centi towards the center. So I'm in this part of the chart. Okay? Now, what I'm going to do is I'm going to go ahead, and it's telling me to multiply by the number from this box. So what would I do to this 8? I would multiply it by, 0.01. 8 times 0.01 is what? Anyone want to take a guess? I know some of you have calculators. Take them out. Mr. Biebrick. It'd be 0.08 meters, and that is the correct answer. Okay. Now, I'm just going to do a hypothetical. If I was going from meters to decameters, if I was going from meters to decameters, what would I do? So I know you know it. You've got this down. Mr. Yoder. I would divide by what number? Okay, I'm going from meters to decameters, so I'm going to divide. Now I'm going to divide by 10. Braden, I'm going to go from hectometers to meters. Okay? Hecto to meters. I'm going to multiply by what? 100. Okay? Amaya, you want to try one? Yes, Maya's going to try one. Maya, I'm going from deci to meters. Okay, I'm going to do what? By what? 0.1. Ladies and gentlemen, if you don't have this chart down, I will leave it up. I know it's getting ready for time to go. Your homework tonight is the following. And I'm just going to write it down underneath this chart.
So we were supposed to copy this chart down? Oh, okay.
Yeah, Finn, I guess you probably should have.
Finn, it's in our book.
Yep. Yes.
Stop.
Yep. No, you're not. No, you're not.
You always say that.
Okay. All right, hold on. This is your assignment, page 28. You're going to do 1 through 7 all, 8 through 16 the evens, 20, 24, and 26. I will leave this up for the next 5 to 10 minutes so that if you need to linger a little bit. We are in study hall time, so when you have this written down in your Mr. Collins class, you need to make your way downstairs. You may come up and ask me questions during study hall time. Amaya?
We did this in 6th grade.
Did you? That's good.